Hi everyone, Hirsch Sah here, reporting from Auckland, it's normal, and today is the 29th of April, 2024. Just sort of bear with me, it's been a pretty busy day at work, and it's now the evening, but I'm trying to get this done, and unlike the previous video being the first part of the lore of space, to be honest, I didn't really prepare for that one, I just sort of spoke. But I've tried to sort of have a bit of a plan for this video. So yeah, hopefully it makes it better, or I guess we'll see. So yeah, as you know, just summarizing from last time, the first video on the lore of space, basically just a quick summary, we went over, the basics of space near Earth in terms of, where space begins and low Earth orbit, and how satellites, work, and how far away they are, and even just basic rocketry, firing rockets into space if you want to escape the Earth's gravity and then go to, say, another planet or the moon or Mars, for example. Um, and even we spoke a little bit how rocketry had started, and of course the space race itself, where things really, went forward. Starting in 1945, at the end of World War II, you had the beginning of the Cold War between the two superpowers at the time, the United States in the West and the Soviet Union in the East. And it was interesting all the firsts that the Soviet Union had, but still it seems that the United States pretty much, well, at least officially, what we've been told, what's been recorded in history, officially the United States won the space race as they were the first to get to the moon, as you know, on the 20th of July 1969 with Neil Armstrong and Buzz Aldrin. Since then, I think it was about 9 missions in total that they did to the moon, with the last one being December 1972, still well over 50 years ago. But that was, again, officially the last time people went to the moon. No one, as if you believe the current records or we have access to, no one has been to the moon since then. And of course, now not only do you have the United States government, if you like, almost in a new space race, aiming to, try and start things up again and even aiming to get to the planet Mars, because no one has yet set foot on Mars. But, you've got other governments as well. It's no longer just the two-horse race or, like a duopoly, just the two superpowers. You've got United States, you've got China, India, Japan. The Indian space race, or the Indian space program, has been very interesting, and they've really achieved some feats as well. And then again, you've got private companies as well, such as SpaceX, run by Elon Musk. He's aiming to get to Mars and colonize Mars, and I think he's claiming to do it in less than 10 years, or within the next 10 or so years. And then you've also got Blue Origin by Jeff Bezos, who's more focused on the moon. So that's sort of where we are today. Let me have a look at this little list that I've prepared. Yeah, that's where we are today. I thought I'd just actually also let you know that the research I did for the last video, especially on the space race between the United States and the former Soviet Union, was from this book that I absolutely loved. I actually read it twice. Space Race, The Battle to Rule the Heavens by Deborah Cadbury, and just having a look, published in 2006. Yeah, published in 2006, so not too old. And of course, it's the history that doesn't really change. Sometimes we find out more things about history, but I'd still call that fairly recent for what it's about, what it details. And in this video, I'm going to talk more about the moon and Mars specifically, and what is really so appealing about them, and even further than that, why we should colonize them, why we need to colonize them. And this book is actually my favorite book of all time, my favorite book, full stop. The Case for Mars, The Plan to Settle the Red Planet and Why We Must, by Dr. Robert Zubrin. This is actually the second edition of this book. The first edition was in 1996. I've read that one. And this is the second edition, which was published 15 years later in 2011. I actually bought it that same year when it had come out. And again, it's my favorite book, full stop. And Robert Zubrin, no one is more determined on Earth to get to Mars than Dr. Robert Zubrin. And he's just an absolute, I think at least, an engineering genius. And it's amazing the things that he has come up with. And he's written many other books. Another one which was the book after The Case for Mars. This one came out in 1999, Entering Space, Creating a Spacefaring Civilization. This book came out in 1999, 3 years after the first edition of The Case for Mars, which came out in 1996. And Robert Zubrin started up the Mars Society. I think it was in 1998, and they're basically a society that are trying to get to Mars through private means. They're trying to raise money to get to Mars through basically running a private space venture without having to rely on a government, which just seems to delay things and eventually just drop it completely. So yeah, that's sort of where I've got a lot of my material from, especially for the last video from that first book, Space Race by Deborah Cadbury. Um, so yeah, like I said, we talked about the basics of space and leaving Earth and the basics of rocket technology, as well as where we're, if you like, basically up to. We've sent probes to the other planets. We've sent probe to land on an asteroid. That was back in 2001, if I remember correctly. We've sent probes outside of the solar system. And of course, we've sent, again, if you believe the official records, we've sent men to the moon. We've sent, of course, men into space who have lived in space for a long period of time. And of course, there have been people on the International Space Station as well. And I think at any one time there are people up there, so people living in space and adding to our collective knowledge of what it's like to live there and what we can do to improve it. So I thought, let's talk about the moon and Mars. What is so interesting about the moon and Mars? And again, what is the law of space? Why should we even bother? I mean, aren't there, so many problems right here on Earth to solve? If say if it costs just a mere $500 New Zealand to feed a starving child on the other side of the world, or say in the developing world, if it costs us $500 NZ or thereabouts to feed a starving child for a year, why should we pump countless billions of dollars into a dead rock up in the sky? Honestly, why? I mean, I think the answer to that question is an absolute no-brainer to anyone who is truly human. But when you look into it, it can be a bit different. So that's what we'll go into. But first, I'd like to let you know, obviously, you know what the Earth is like, and you know how it's quite friendly to life, at least life as we know it. But the moon, yeah, the moon is, while it's very close, as you know, we can get there by rocket ship using 1960s technology. We can get there in just 3 days. But what is so appealing about the moon? Basically, the moon is very close to Earth. You could argue that if you're sending people to Mars, which takes, from the research I did, about 4 to 9 months to get to, depending on what technology you use and what route you take. If it's taking people 4 to 9 months to get to Mars, it's around about usually 6 months. But if it takes that long for people to get to Mars, and if something goes wrong halfway there, or even on the planet, if something goes seriously wrong, like you're losing oxygen, or you've run out of food, or you can no longer produce food, or you can no longer produce water, I guess you're more or less screwed, to be quite blunt. Whereas a problem occurs on the moon, with the moon only being a few days away, you can always send up emergency supplies, emergency help, what have you, if something goes wrong with the moon. And to be honest, that's probably what makes it very appealing. Even though the moon it doesn't have as many resources as Mars. Mars, like Dr. Rubin says, is further away but offers a much greater prize. So, okay, looking at the moon, basically, as you know, it's a barren piece of rock, no atmosphere at all. Space begins immediately as you're on the ground on the moon, and low lunar orbit or low moon orbit is basically 100 k's above its surface. You might remember from the last video that low Earth orbit is about 200 k's above, say sea level or above the surface. So that's where you can basically orbit the Earth and keep orbiting it. Basically, you will fall at the same rate as the Earth tends to curve. So you'll basically keep falling and basically keep orbiting the planet. Eventually, you will come down and crash into the Earth. Usually, the higher up you are in space, the longer you will stay there. But on the moon, low lunar orbit is 100 k's above its surface, and space starts immediately. On Earth, space starts 100 k's up after the atmosphere, and low Earth orbit is 200 k's up. So on the moon, really, as you can see, it's just pretty much barren rock, a real desert, you can call it, but it still has resources. There are still vital metals that is there. There's a lot of oxygen actually inside the moon. There's a lot of oxygen beds. I remember reading somewhere that 40% of the moon's weight is actually oxygen. So there's a lot of oxygen on the moon. So you might ask, okay, how would we live on the moon? And if we decide we want to expand to the moon, colonize the moon, develop the moon, how would we live there? I mean, yes, it could be extremely exciting to live there and just everything we do there, whether it's photography, whether it's movies, whether it's sports games, whether it's TV shows or music or just everyday living, perhaps a reality show. it would certainly be very, very exciting. And it's the sort of thing that with the moon being quite close, people don't have to even live there continually. They can go up to visit and they can come down and back to Earth, whereas that's not really the case for Mars. If you're going to Mars, you probably want to stay there with the time and effort and cost that it takes to get there. But on the moon, really, how can you live there? Okay, so obviously you can live in spaceships, and you can, when you go out walking, you have to be in a spacesuit because there's no oxygen, and the pressure obviously is not right for the human body to live. Um, but again, in terms of living on the moon, at least in simple terms from what I've read, of course, there are a lot of specifics and you can go into a lot of detail. But living on the moon, you would develop domes, perhaps glass domes that are thick enough to shield human beings from, the sun's harmful rays. Because you don't have an atmosphere to protect you from it like you do on Earth. There's no atmosphere for that, no ozone layer for that. But you would live in big glass domes that are thick enough to protect you from that. You would bring plants from Earth, and I'm not sure if you can grow them in the lunar soil. You'd probably bring some sort of soil from Earth, and you'd grow the plants in that soil. The plants would in turn give you food and oxygen, just like you or human beings would give the plants carbon dioxide. So it would become a bit of an ecosystem. It would work in that sense. Power could be generated through solar panels easily because without any atmospheric disturbance, you would generate much, much more power from just basic solar panels on the moon than you would on Earth. So that would work very well for power. And of course, like the plants that you plant can give you food and oxygen, you can also mine oxygen from inside the moon because the moon has a lot of oxygen within it, as mentioned. And there's also, the rocks and metals that you can use for building, that you can use for all sorts of things, maybe even bringing back to the moon, back to Earth, like as an export. They've talked about helium-3, which is really collected up on the surface of the moon through solar flares. And that's a very valuable resource. I think for energy, it could be extremely valuable on Earth. So there's a valuable export the moon can provide to support a growing colony there. And yes, as the moon grew and became, more and more developed, it could probably eventually become self-sufficient. It could just keep expanding based on what it already has there, from the plants that are already there, from the soil that is already there, the human beings, and later on introducing animals. It could probably just keep on expanding from what it has and keep on producing oxygen, food, water, and all that. And it could eventually become self-sufficient. And so I think I actually forgot to mention water. How do you get water? I mentioned oxygen and food. You'd use metals for building and all that. How would you get water on the moon? Yes, basically, they believe that in some places on the moon, especially at its poles, I think especially the South Pole, where the recent probe sent by India, Chandrayaan 3, which recently landed there, I think it was August 2023, August last year, that landed in the South Pole of the moon and actually discovered a lot of chemicals, even valuable chemicals, in the lunar soil or the moon soil, which had not really been discovered earlier by any country's rovers or space missions. So coming back, how would you get oxygen from the moon? Well, you could bring hydrogen. Sorry, not oxygen. How would you get water from the moon? You could bring hydrogen from the Earth and combine it with oxygen, available inside the moon, because a lot of it is oxygen. You could combine the hydrogen with oxygen to, of course, create water. And of course, you would need that water to feed not only yourself and for cleaning, but also to feed the plants which would grow and in turn provide you with food and oxygen. And of course, you would, recycle water. That might not sound very appealing, but when you had it in much large enough quantities, you could keep recycling it, just basically as the Earth does itself. So that is basically how you live on the moon. Say if we talk about Mars, which is of course the fourth planet from the solar system, the moon is much smaller than the Earth and lacks a lot of resources and is basically just a rock in the sky, basically a desert. Mars is much different. Mars actually has all the resources needed for man not only to survive, but in fact thrive, to create a technologically advanced civilization. Mars has an atmosphere only about 1% as thick as that on Earth, but still strong enough to protect you from, the sun's harmful radiation. Mars's atmosphere might be very thin and it's mostly carbon dioxide, even though it's about 95% carbon dioxide. Even though that might sound horrible, there's not much of it because it's such a thin atmosphere. And then Mars has, of course, soil, and the soil on Mars, they believe, is much more fertile than previously thought. So how would you live on Mars? Obviously, when you first got there, you'll probably start off by living in the spaceships that you traveled in to arrive there. And that's actually what Zubin has talked about with starting the first colonies, that they simply live in the spaceships which they use to get there once the spaceships have landed. And of course, they expand, they build more buildings and everything. But how would you live on Mars? In basic sense, you would bring genetically modified plants from Earth and you would plant them in the Martian soil. Maybe you might first plant them in Earth soil brought over from Earth to start them off, but eventually you'll be able to plant them in Martian soil. And basically, as the plants grow, what would happen is it is believed that they would absorb more light from the sun, which would start to heat up the planet. Because the other thing with Mars, it's a very, very cold planet. The average temperature there is basically 0 degrees. On Mars, it can be as cold as it is in Antarctica, sometimes even colder. So what you would do is bring the genetically modified plants from Earth, plant them in the Martian soil, and of course you would bring some water and whatever you need to start off with. The plants would start to grow, absorb sunlight in order to do so, and make the planet a bit warmer. Also, what you would do is Mars has polar ice caps, and I'm sorry about that, it's just my stupid phone going. Mars has polar ice caps, just like Earth does. Its northern ice cap is actually mostly water ice, and it is believed that in the past Mars was a warmer planet with oceans, a warmer, wetter planet with oceans, just like Earth. And they even believed that it had life, vegetation, and perhaps even not just flora but fauna, animal life as well as plant life. That's what they believe was there in the past, and who knows? As we speak, there could be a lot of fossils up there just waiting to be found. If there was past life on Mars, both plant life and animal life, there could even be oil there. Who knows? Who knows? Of course, I don't know, but I guess we won't know until we get there and do a bit of digging to find out. But basically, what you would do on Mars is that the northern ice cap is mostly water ice, and when you look at the topography of Mars, you can see that it looks like what was once what is basically a large basin in the northern hemisphere. The northern hemisphere is quite flat with a huge basin around that ice cap, and it looks as if that basin used to be an ocean. It looks like it's a remnant of a ancient ocean, and then somehow something happened to the planet. It froze over, and the water, which was once liquid, froze into ice, and is now the northern ice cap. The southern ice cap on Mars is much smaller, but that's actually carbon dioxide ice. What both Zubin and other scientists have theorized is you can actually make Mars much more habitable and convert it into, if you like, a second Earth. Yes, it is further away than the moon, but it has so much more to offer. Everything we need to survive and thrive is mentioned. So Mars, really, it may be much further away, but as Zubin says, offers a much greater prize. But scientists believe that you can, what they call terraform Mars. And terraforming is a process which is applied to any planetary body which is not Earth-like, to make it more Earth-like, with land and vegetation and oceans, a thicker atmosphere, oxygen. So what they thought to do with Mars is first, you would actually melt that southern ice cap, whether it's through a nuclear bomb or missiles or mirrors in the space reflecting more sunlight onto them or sprinkling black ash on them to attract sunlight and melt the ice. You would melt the southern ice cap, which is CO2 mostly. That CO2 would disperse around the planet and create, as we know very well, a greenhouse effect, which is unfortunately what's happening on Earth now with our burning of fossil fuels. Carbon dioxide would increase on the planet. As carbon dioxide increased, it's a very good heat trapping gas. The average temperature of the planet would warm. And like I mentioned, you would plant plants on there to also attract more sunlight to the planet. Once the planet warmed through doing those things, the northern ice cap, which is mostly water ice, would melt, and that would create an ocean like it used to be perhaps in the northern hemisphere. That ocean would in turn feed the land, and nature would take its course. The sun would shine on the ocean. If it start to evaporate it, you would have rainfall throughout the planet. A lot of the planet would start to become moistened, and if you had already had some vegetation there, more vegetation would likely emerge or be much easier to spread that vegetation. As you spread the vegetation, it would grow and, like what vegetation does, absorb the carbon dioxide and it would expel oxygen. And hey presto, maybe easier said than done, you would have an Earth in time. It may take centuries, possibly even 1 or 2 centuries to do that, but it could be done. And of course, it's one of those things, that you would look at for the long term. So that's the appeal of Mars. I mean, the moon might be much closer, it might have ice at its south pole, which could be converted into water and all that, or we can make water by combining hydrogen from Earth brought over with oxygen from inside the moon. You've heard it, but Mars can really offer you pretty much everything we need to survive, as well as thrive. It could really become a second Earth. It's also a much larger planetary body than the moon. The moon is roughly the size of North America and South America combined, whereas Mars, which is about half the diameter of Earth, the diameter of Earth is 12,756 kilometers. Mars's diameter is about half that. So basically, the size of Mars, or the area of Mars, is about the size of all the land on Earth. If you think the 7 continents put together without the oceans, that's basically the size of Mars. So that's really what the moon and Mars have to offer us. But now coming back to okay, why? Why should we bother with space? I mean, that all sounds great. Hey, make a good movie, you might say. And obviously, movies have been made on this. But why the moon? Why Mars? Why space? Well, basically, like what Dr. Zubin argues is that we have to keep expanding. People, you might say, oh, but aren't we already very advanced? It's amazing, with this little piece of plastic, I can talk to someone on the other side of the planet, or I can order a car like that. I can find a girlfriend. Hasn't really worked for me so far. But like you can do whatever you want, or online shopping, whatever you want. But at any one time, people would have said that. Whether you talk to people today, whether you went back in time and spoke to people like 500 years ago or 1,000 years ago, they would always say that, yes, our technology is the best because chances are it's the best it ever has been. But really, without trying to sound, like we're overdoing it or even being too greedy, you have to keep on expanding. You can't just stop because chances are if you stop, you will start to decay. And Robin Zubin talks about comparing the human beings colonizing Mars to human beings, or if you like, the earlier European colonialists who colonized North America. I think it was the Spanish who actually first discovered North America. They were using ships that were really designed for the Mediterranean. But they took on the vast North Atlantic Ocean, and obviously a bit like traveling to Mars today. If something happened in the middle, they would be screwed. They really couldn't, just shout out for help and receive it as soon as they needed it. So, it was actually the Spanish who first discovered North America, but they didn't bother claiming it. They just thought, oh, too far away. A little bit like some people might think of Mars now, or even the moon. But and they left it. But also British who later on colonized North America. And what happened is that forced them to work hard, to have breakthrough after breakthrough, to move forward, to develop a lot of new technologies. And that is how they became, at the time at least, the wealthiest nation or the wealthiest race. Yes, of course, yes, they did use slavery and what have you. And of course, not everything they did was ethical. I think no race or, firm or business ever does everything 100% ethically, do they? But the point is that they did expand and they created America in the process, and there was a lot of innovation, sometimes referred to as Yankee ingenuity. So they developed the United States, as we know now, and the United States ended up becoming more advanced and wealthier than they were back in Britain, even though they had obviously started much earlier. And then other European countries, wanted to catch a bit of the newly found wealth. The French came as well afterwards, but they had to settle for what is now Canada. That is why in Canada they speak French. The Spanish did, also come back to, see what they could enjoy, what piece of the pie that they could have. But they had to settle for what is now Mexico, and that's of course why Mexico, they're originally Spanish people who went there. And I think they also went into South America, and that's when you had the Spanish conquistadors. So a bit like how the early European explorers, settlers, colonialists, uh, discovered and then developed North America. Zubin argues that's what we need to do with Mars, and the secret is not to take everything there because that will just not work. It'll be risky. It'll be too hard. It'll be too expensive. But what he put is travel light and live off the land. And you already heard how Mars can be terraformed and lived on. He actually developed a very interesting model for getting there much more easily, much more safer, and even much cheaper than before. It was in 1989 in the United States when Bush Sr., George Bush Sr., was the president, and he had actually signed on the 20th anniversary of the moon landing. So this was the 20th of July, 1989. He actually signed in the plan to for the Americans to get to Mars, and a Mars mission pretty much began. Unfortunately, it completely fell over not long after that. In 1990, the government released what they called their 90-day report because it simply took 90 days to create. And the 90-day report concluded that to get to Mars, they would need an absolute massive, if you almost like Battlestar Galactica sort of spaceship. It would be so large they could not even launch it from Earth. They would have to launch it in parts and then be assembled, put together. Oop, I can actually do this probably, but put together in space. Because they would carry absolutely everything they needed, including food, water, oxygen, their vehicles for on Mars, and everything they would take onto Mars, and even the fuel to get there and get back. And therefore, the price at the end of the day was going to be $450 billion, and this is in 1990. Don't forget. And that of course scared Congress away from it for quite some time, and the project basically just completely fell over. It would be the largest spending America took since World War II. But then Zubrin came along and he developed a much better, like I said, a safer, better, and more cost-effective model. He developed what he called Mars Direct and would only be 50 billion, 50 billion US, possibly even it could be whittled down to even 20 or 30 billion. He even calculated that had it been done on a private scale, it could be as little as 5 billion US. And of course, that's still a lot of money, but it would start the ongoing, human presence on Mars. It would start the development on Mars, the colonization of Mars, and of course paybacks would come. And he said, what you do is you just travel light and live off the land. What you do, you first send one small spaceship, unmanned, no people on it, to land on Mars. And what it does, not only does it have a hab and food and supplies for a crew, it also starts developing fuel for the return journey when people get there. It develops fuel by taking in the Martian atmosphere, which is mostly CO2, and I think mixing it with a bit of hydrogen brought over from Earth. So, in order to create methane, and they actually tested this and it worked, to create methane which could be used as a rocket propellant. So, their first spaceship goes there and lands there and starts producing methane for the return journey when people get there. There's a good launching window to get to Mars every 2 years. So, in the first year, they send that. 2 years later, year 3 if you like, once it has produced enough methane for the return journey, they then send out 2 spaceships, one which is manned and another which is unmanned. The one which is unmanned is going to land in a different spot and do the exact same thing as the very first spaceship. Land there, have housing and supplies for a crew of 4. I think it's for 1 or 2 years, or a good length of time, or a long length of time. But the first spaceship of those 2, which is sent in year 3 after the original 2 years earlier, that first spaceship of 2 will actually have a crew of 4, and they will land in the same area as the first spaceship landed, and they will have return fuel for their return journey, so they don't have to carry all of it, and therefore it's much easier for them to get there. It's much lighter, it's less dangerous, and of course, it's cheaper. And this would continue. And people would go to Mars, explore it, make discovery after discovery, even develop new technologies, and they would come back. And then eventually, people start to stay on Mars, and you'll start to build a society, a colony, and you'll go from there. And it's just one of those things. It's amazing how technology is, things that seemed so hard, even impossible, but eventually just through technological development, it becomes easier, and there are many examples. When the first cars came about, they were constantly breaking down, they were very expensive. It's hard to believe today, especially where I live in a city like Auckland in New Zealand, that only 100 years ago, cars were more expensive than houses because cars were very rare. It took a lot to build them. There was no sort of mass production. The technology was far behind. And as for houses, well, there was so much of land available, more land, more supply of property than really demand for it. Today, unfortunately, it's the opposite. There's much more demand for property than there is supply. And that's, of course, why house prices are very high, especially where I live in Auckland. But cars back then, were very expensive and hard to produce. But today, it's all mass produced. It's on an assembly line. They use computers. They use machines. They export to other countries where they can find things that are cheaper. And it's just amazing how quickly they put them together. And that's why they're so cheap, And the same thing can happen with space. Just as you advance, things become easier, things become cheaper, things are exported to other countries. Things are done. You have economies of scale eventually, which again brings down the cost. You have different businesses that come into the industry or the newly created industry and they compete, again bringing down the cost or the price. And that's just how it goes. And another example is computers. The first computers, which were the sizes of buildings, they needed their own cooling plants. And you would never think the way they were back then that you could ever have, if you like, a desktop personal computer, a laptop personal computer, or a computer that you could hold in your hand. You would never think that back then that would even be a possibility. But of course, now it has. And not only is a computer you can hold in your hand, but it does a hell of a lot more than computers back then, which were the sizes of buildings. And of course, it's much cheaper. And the same thing happened with airfares. Airfares have come down dramatically because we've managed with our technology of producing planes and also being able to use the planes again and being able to offer, in bulk airfares and all that, and people continually traveling from here to there, and so many people offering the services. You get the idea. It's come down in price dramatically. The same can happen for space. It really can. And again, it would advance us. We would have one breakthrough after another, and it's just what we need. And on that note, that's exactly what happened with the moon landing. The moon landing or the Apollo space program of the 60s. What did it really do? One thing it did, especially which was relevant to so many people, or even just the whole planet, it gave us satellite technology. And with satellite technology, we had telecommunications, the internet, mobile phones, all that, GPS. Today it's hard to imagine our lives without such things because we depend on them so much. We use them every day. But that actually came about, believe it or not, because of the space program back in the 1960s. It may have cost 20 billion US back at the time. And don't imagine how much they'll be when you adjusted it for inflation. This is back in the day when houses were just $10,000, a decent house too. It may have cost 20 billion US back at the time, but it has been paid back many times over. And again, not saying that we shouldn't, coming back to that question I had towards the beginning of the video, not saying that we shouldn't support children in starving countries. Of course we should, we need to, we must. But a little bit like that video I had a few talk videos before, there are different types of problems, and yes, they're at different magnitudes, but you can't just say that you ignore one problem because there's an even worse problem. You have to attend to them all. You really have to attend to them all. Of course, we need to attend to starving children in the third world. And again, on that note, one problem with that, and I think this is the real reason why some people don't donate to a charity, is that you really wonder where the money's actually going. A lot of charitable organizations, we hear that a lot of the money or the majority of the funds that they raise or majority of the money that they fundraise actually goes towards their own running costs as opposed to the actual causes that they stand for, which of course is sad and not what people want to hear. And I think that's why a lot of people don't donate to charity, not because they are greedy or anything like that. And even if you started, giving a lot of money to, say, African countries or Asian countries or South American countries, I'm not saying this would always happen, but what would likely happen is that, the money, you wonder how much really goes to the actual children who are in hardship, the people who are starving, the people who are in poverty, the people who need it. A lot of it's probably just going to get absorbed by, corrupted, government officials and corporates who think they're greater than gods. And that's probably, sadly, where it will go. So there's also that to consider. What we really need to do is teach these, these other, these different countries, these developing countries, to find ways to survive on their own, to make the most of their own strengths, their own advantages, whatever they are, and become self-sufficient. And then even beyond that, good examples of countries that have done this are China and India. Countries which were as recent as the 1980s for China and the 1990s for India, countries which were labeled as third world, backwards, gone cases, and now they're upcoming superpowers. They can compete with the likes of the United States and Europe. As you've seen, China and India even have their own space races now, and it looks like India is really accelerating in it. Of course I could be wrong, but at the rate we're going, it looks like the first man on Mars will actually be an Indian. It makes you think. So that's what we need to do with those sort of countries. If we just those developing countries, if we just keep giving them money, chances are they'll just keep relying on it, and they might not even move forward at all. money, especially when it's there, needs to be spent wisely. It needs to be used both efficiently and effectively, which can certainly happen, with investing it in space. Again, provided it's used properly. As we've seen, NASA has really not done a hell of a lot since they sent up Skylab, the first space station, back in 1973. This is 51 years ago, because even though they've received a lot of funding, they've become quite corrupted and they've really lost a focus, especially without having a competitor there. During the 1960s, they had a real aim given by, former President John F. Kennedy to get to the moon before this decade is out, before the end of the 60s, and they were competing with the Soviet Union to do it. Now that real aim is not really there, and that close competition is not really there either. So it's sad what's happened. But if the money is used well, whether it's done on a private basis or a public basis, or even combination of the two, which could be an answer, yes, we could get to the moon, we could get to Mars, and we could expand and have absolutely no limits. The sky will no longer be the limit, which seems to be the case today. Also, expanding to the moon and Mars will, if you like, give us a backup of life, life on Earth. So, say if something happens to one planetary body, say if we expanded to the moon, even just to the moon, for example, if something happens to either the moon or Earth, you have the other planetary body, so the life can continue going. As Carl Sagan said, a real space enthusiast from the 1960s, who, if I remember correctly, actually came up with the concept of terraforming, converting a planet which is not Earth-like into an Earth-like planet. Carl Sagan actually said, and he first proposed the terraforming of the planet Venus, but then, of course, we found other planets which were better candidates afterwards. But Carl Sagan was one who said, all planets either become spacefaring or extinct. Sorry, not all planets, all civilizations either become spacefaring or extinct. So, certainly makes you think. Also, lastly, some people will say that, the moon and Mars, whatever you want to argue, it's not ours, or it's not ours to conquer, or, we can't just claim it, or what gives us the right to ruin another planetary body in the same way they will ruin this one, the Earth? What gives us that right? You have to remember that the moon and Mars are seriously different. Earth was teeming with life before human beings, and sadly that's changed a little bit since human beings have come on the planet. The moon and Mars are already pretty much dead planets. By colonizing them, by bringing life to them, we would be giving them life, not taking it away. And I truly think if there's anything we can do to make up for the damage we've done here on Earth, apart from obviously trying to undo the damage, but if there's anything we can really do to make up for that damage, it's by spreading life to other planetary bodies and really making it everlasting, immortal. And that's what space can give us. That is the law of space. So I think that's pretty good time to end here, and hopefully I've given you plenty to think about. Thank you.